Hello, everyone, and welcome to a new session of Dr. Spotfire. I'm your host, Athir, and today I'm joined by Farouk Askari, who's a colleague of mine and account technical strategist at Spotfire. And then together today we will dive into a use case to predict ESP failure from ESP data. So, a couple of housekeeping items before we start. To those who are joining us the first time, I would like to introduce you to Spotfire. So, Spotfire is a visual data science platform, and this means it's not just a tool, but it's a platform that enables you to create low code and no code visual analytics applications to solve complex industry problems. The types of the use cases that Spotfire addresses are not traditional business analytics or business intelligence problems, just like the one that we are going to discuss today. We have industry-specific solutions like custom visualizations for upstream energy, high-tech manufacturing, and life sciences, among all other solutions also. And Spotfire focuses on visual data science, is meant to convey the interaction and real-time data, connectivity and performance visualizations, and advanced data science. So that's very quick what Spotfire is all about. And then moving on to our team. So Dr. Spotfire program is basically designed to help new and also advanced Spotfire users uh, to let's say get better insights and tricks, and then maybe get exposed to industrial use cases, just like the one that we're going to talk about today. Uh, and also, the program itself is live every first Tuesday of every month, so it's monthly. Don't worry if you miss the session. We always have it recorded on our YouTube channel, along with a large amount of quick tip videos and other resources. So, how does Dr. Spotfire works? The Dr. Spotfire program is aimed to, as we said, help the new and advanced users, and it's hosted by three experts, joined by other Spotfire team members, partners, and customers. We also have another variety, or like another product is quick tips videos. These are like short videos that teach you one or two tricks in Spotfire, and they can range from, let's say, beginner level to advanced level. Uh, and it's all driven by you, our community. We have ideas portal, we have our Spotfire community, we have our social media channels, and we also have our Dr. Spotfire email. That's doctor@spotfire.com. You can send us all your questions, all your suggestions for the next sessions, and then we can discuss that. So you can see that we can get feedback from ideas portal, from community, from LinkedIn, from social media channels, YouTube, and then all of this will be translated into either quick tip videos or Dr. Spotfire sessions. Um, and our motto is learning is not driven by answers, but by questions. So we like to kick off the our presentation with this motto. This is our confidentiality disclaimer, and today we have Farouk Askari and me myself, and then she will start talking to you about the ESP use case. Farouk, welcome to the Dr. Spotfire session, and floor is yours.
Thank you, Atir. Hi, everyone. Nice to meet you. So for today's use case, we've chosen ESP pump reliability, and we're going to showcase that and just a little bit about the agenda that we'll discuss today. I'll give an intro into ESPs themselves and talk through the use case, and we'll showcase some different techniques that you've used within Spotfire to visualize the data, and we'll wrap up at the very end. So next slide, please. So before we get into, before we get into what is an ESP, what I wanted to highlight, a broad range of use cases that can be solved using Spotfire. Regardless if you're a production engineer, a reservoir engineer, a drilling engineer, these are all different use cases that can be solved using Spotfire. And the particular one that we've highlighted today falls within predictive maintenance, right? So predictive maintenance of pumps, in this case, electrical submersible pumps. But really, there's a library of use cases, right, that you have access to. And if we had all the time in the world, we'd highlight all of them. But if there are any particular ones that are of interest to you, feel free to let us know, and we'll cover those in future sessions. So with that, let's talk about ESPs. Next slide, please. So for today's session, like we said, we're looking to optimize the pump reliability through predictive analytics and predicting ESP run life itself. So for those of you that are not familiar with ESPs, they're electric submersible pumps, and they're designed to move high liquids of volumes. Now, these can be in upstream oil and gas applications, which is, the data set that we're going to utilize today. But you can also use different types of pumps in other applications, right, within downstream applications in refineries, in petrochemical facilities. So the concept of predicting the run life of a particular pump is very similar. And the steps that will follow in the presentation today are pretty similar, regardless, if you're looking at an ESP, in a downstream application or an upstream application. So I just wanted to highlight that as well. Now, in this particular data set, in this particular use case, there are over 200 plus active ESPs that we're going to be looking at. And, these have about a 12-month average run life. And there's typically 150 plus repairs every single year. So this, averages to 3 repairs per week, which requires quite a bit of, of course, resources, being on site and facilitating and working through these failures. Now, why would a electric submersible pump fail? There's many reasons why different kinds of pumps fail, but in this particular case, some of the reasons could be the process conditions themselves, right? So typically we would have, gas interference, depending on when we're operating the particular well. You could have sand, right, coming through your pumps, which can cause some, different functions within your pump that could potentially cause to erosion and different types of failures of your equipment. There could be different trips associated, again, all related to the process conditions. And there could be other defects, right, within your well itself. So drilling and completions defects, maybe the design of the ESP itself, or perhaps the particular pump that was used was not properly designed or sized for the application that it's being used in. So there's a ton of different reasons why your ESPs could fail, and of course there's a lot of financial costs associated with that, right? These could cost thousands and hundreds of thousands of dollars in repairs, but also you have the downtime that's associated with these pumps being offline. So lots of value here in terms of being able to predict the run life of these pumps and running your plants and facilities much more efficiently. Next slide, please. Thank you. So for the objective of this session is really to develop a data-driven model to estimate the ESP run life. Now, because we only have a short period of time today, we're going to cover the first bit of, getting to building this particular model. And in the future session, what we'll do is we'll actually highlight how to build the model within Spotfire and walk you through evaluating the particular model itself. But for today, what we have access to is a time series data set. So these are 70 different wells that have been anonymized. And I just want to give a shout out to the VPX Machine Learning Challenge that happened last year. This is the anonymized data set that we're utilizing today. So there's 70 wells with 145 ESPs which have failed within this time series data set that we have access to, and about 60 of them that are still currently running. So it's a pretty large data set that contain different variables and features like your temperatures, frequencies, currents, and production information such as your flow rates of your oil, your gas, your water, and different pressures of your casing and tubing itself. So lots of variables to look at, as well as the frequency of the different data sets that we have, and the different features vary. So for example, typically flow rates can be much lower resolution than your pressures or other temperatures that you're looking at. So we'll kind of highlight what kind of data we have access to as well. And then we also have an ESP tracker data set that summarizes all of the ESP data sets, all of the ESP data within the 70 wells that we have access to. There's tons of columns within that particular data set. And they have some information around the installation dates, the failures, the work orders, for example, that may have been associated with the particular failure or maintenance event that had occurred. So we have access to a lot of good data, and we wanted to kind of walk you through how we go about exploring that data and using it to build this data-driven model to estimate the run life of the ESP. Next slide, please. So what I'm going to do is I'm going to talk you through the first step, as I mentioned, of the exploratory data analysis, and pass it over to Atir, who helped us out here today to get started. But really the goal of any type of project like this is to create, a data, a combined data set that utilizes all of the data that I just spoke about, that you can actually go and play around with, right? And there's many steps that you have to follow, whether it's looking at missing data and outliers and correcting for them, adjusting your sampling frequency to make sure you have a proper representation of your data, before you can do any sort of descriptive analysis and, build some of the visualizations that we have done within Spotfire. So Atir, I'm going to pass it over to you if you want to talk through some of the steps that we followed.
Yeah, sure. So just like Farooq mentioned, that we started by looking at the provided data, and then the data itself, it's in two parts. So there's, let's say, the wells individual, or like the wells time series data, and there's the tracker data, or the events data, and that captures let's say all the activities, the events that happen in a specific well, or like on a specific pump. So let's say if you pulled the pump, if you installed a new one, what was the correction, like what was the, let's say, failure date, how long it took you, let's say, from the failure until you replace the pump, these kind of data. And then the point is, or like the goal of the analysis is to kind of like map this metadata, or like put this metadata on a time series, or on the timeline of these individual pumps to toward, let's say, the ultimate goal of predicting when a failure will happen. And then once we know, let's say, the point where a failure happened, then we can look at all, let's say, the serious events, or like all the serious behavior before that event. For example, do we have, or like do the pump experience any anomalies in like in their frequency, let's say days before the failure? Are there any, let's say, vibration indicators? Do we have an increase in the gas rate before the failure? So all of these indicators, but we start by bringing the tracker data. So we have here the tracker data, which is basically a record, or more than a record, per pump, and then all the metadata that's related to that pump. For example, the made, the cable type, number of stages, all the metadata that's related to that pump, and also the event type. Like, what do we have here? Are we pulling the pump? Are we installing a new one? Is this like a failure event? So what we did is in Spotfire, for each well, we mapped data from the tracker data as a new column to that well data to create, let's say, a new data set that has the well readings plus all the events that happen through the say uh, uh, that life time that we were provided for that specific well. And after achieving that, we started looking at uh, in a descriptive way the data for individual wells and also the data for the tracker, because we might get something out of the tracker. For example, do we have, uh, let's say, a high rate of failure for a specific manufacturer, or do we have, let's say, a high rate of failure for a specific type of clamps or for a specific type of impler, these kind of things. So we started by also looking at the motor frequency and also the intake pressure to kind of like trying to relate that or like resonate that with the failure of individual pumps. And then we also looked at uh, uh, the events for all the provided wells. And as Farouk mentioned, we have around 70 plus 70 wells provided to us. And then, as we mentioned, this at this stage, all what we are doing is we are looking at the data. We're not, let's say, uh, uh, pulling any conclusions. We're just exploring the data. That's from the name. It's exploratory data analysis. So we're just exploring the data, trying to find if there is any uh, significant patterns, or if there's any, let's say, correlations between the different variables. Why we're doing that? Because that will help us in the next stage, which is the feature importance and the modeling, and then will help us on deciding what to choose to include in our model. We also looked at the component that fails, let's say the breakdown, and then this is a breakdown. It's not clear, but for example, this is like a cable component, usually on the top of the pump, uh, that is usually failed, and then this is like the pump component itself that also usually fails. And then this is the status per production model. So we kind of like broke down the failure and the, let's say, the pumps that are still running per manufacturer, or like per model for pump, just to see if like a specific model is more likely to fail than others. And this might be like a design decision that can help us in the future. And then, as we said, this is an exploratory data analysis stage. So we're still exploring the data to look for patterns and correlations, preparing to the modeling stage. Um, yeah, so this is this is the end of the exploratory data analysis stage. Farouk, do you have anything to add, or?
Yeah, I think some of the interesting things that we found was, there was, I don't think it's super clear to read in this presentation, but I think we found a couple of different models that were more prone to failure, right? So, some of the conclusions that we made was, could it be the fact that that particular model was not designed or not intended for that particular well, and that process operation itself, right? So there's a lot more to dig deeper into to understand why a particular model may have failed. Of course, looking at the different conditions of the well itself, right? The gas flow rates, if there was sand going through these pumps. So there was a ton of data to look through, and I think we went over it pretty quickly in the session here today, but just the process of merging all of that data for the 70 different individual wells, and cleaning up the data, making sure we didn't have any outliers, and tracking the missing data took quite a bit of time, especially since a lot of this data is either manually entered or not necessarily, tracked as well
Correct.
as we all hope. So that part takes quite a bit of time to kind of organize and get put together before we can analyze it like this in Spotfire.
Yeah, and then that's also like one of the challenges when we move from the very clean and controlled data science environment that we have in our simulations or like on our examples to the like real field data. You'll face a lot of challenges. For example, missing data, outliers, like data that were, let's say, misentered, or like, I mean, maybe like an extra zero will like, yeah, throw all the results off. So a tool like Spotfire will give you, let's say, a very quick way to kind of like look at the data all at once, relate some of the variables, and then see if you have quickly if we have like any patterns, any outliers, and then also will enable you to kind of like decide what to do next. Like for example, for the outliers, we have a couple of data functions and also um, uh, let's say mods that can help you to decide how to treat your outliers. For the missing data, you can also have a couple of options on how to like impute or drop your missing data. We have also a couple of data functions that you can study the feature importance when it comes to modeling the important variables. And all of that can be done in a very interactive way, in a very collaborative way. So not only you, all the, let's say, the team members can see what you're doing, chime in, maybe add their suggestions without affecting what you're working on. So this has been fun project to work on and to continue like working on and think about. And it's just like any other data science project. There is no definite answer. It's like a very kind of like open-ended problem. You can uh, you can see multiple approaches on how to solve this problem. And Spotfire provide you, let's say, a platform on how to do that. So this was it for today's session. I wanted to mention that subscribe to our YouTube channel if you missed this session, or if you want to rewatch it or like rewatch any of the previous sessions. Everything is recorded there on our channel. And also, don't forget to share your thoughts, suggestions. We'd like to hear from you. You can simply just email doctor@spotfire.com. And that goes also for questions. If you have any question, make sure you post that questions in the community. If you didn't get any response, you can just simply send us an email, and we will happy to help you. Okay, so this was it for today's session. Thank you for joining us, and we will see you on the first Tuesday of the next month. And have a great day. Thank you.
Thank you, everyone.